Precalculus, Chapter 2.3 exercises 17 through 20 and 25 through 28. In this exercise set, I'll be doing the odd number problems 17, 19, 25, and 27. In this first set, exercises 17 through 20 graph the function in a viewing window that shows all the extrema and x-intercepts. This exercise set is intended to be mostly an exercise in graphing using the graphing calculator. In this case, I have a TI-84 CE calculator, and then describe the end behavior using limits. However, I want to also address how, at least in this factored form, how we might know where zeros are. And to find zeros, if we set a function equal to 0, if we have 0 equals quantity x minus 1 times quantity x plus 2 times quantity x plus 3, we can use what we call the zero factor property, which is anything times 0 equals 0. So we have x minus 1 is equal to 0, and therefore x is equal to 1. That's one of our zeros. Then we have x plus 2 is equal to 0, therefore x is equal to negative 2, and finally we have x plus 3 is equal to 0, therefore x is equal to negative 3. And so our zeros are going to be x equals negative 3 comma negative 2 comma 1, each with a multiplicity of 1. And so looking at an xy coordinate plane like this one here, we mark our zeros at x equals negative 3, negative 2, and 1. And then we can look at the nature of the function. We can tell the nature of the function by multiplying all the x's together. X times x times x is going to be x cubed. Now this x cubed is our leading term of the function, and this one has what we call an odd nature, or an odd degree, making it an odd-natured function. And also we say this is a positive. Well, odd positive will start low and end high, and so it would look something like this, starting low here from quadrant 3, and we touch negative 3 and cross and go up, and we come back down again at negative 2, we touch and cross. We go down here and we touch and cross at x equals 1. So that's what it's going to look like. Let's go ahead and put this in the calculator, and I previously entered this factored form of problem 17 here, and I'm going to graph. And this is really using a standard window. We see all the x-intercepts, we see all the extrema, which would be the maximum and minimum points. So let's go ahead and check our window here. The acceptable window, that's what it's asking for, is x minimum negative 10, x maximum 10, y minimum negative 10, y maximum 10. So appropriate window, I'm going to just write this down. X minimum equals negative 10. X maximum is equal to 10. Y minimum is equal to negative 10. And y maximum is equal to 10. And then the last thing we have is end behavior. And for end behavior, we articulate that thusly limit as x approaches infinity of our function f of x equals, and if we go to the right, we are going to go towards positive infinity and the function ends high, so that is our answer here. And for the other way, limit as x approaches negative infinity of f of x is equal to negative infinity. So that's going to take care of problem number 17. Okay, let's go on to the next under problem, which is 19. And in this case, we are not given a factored form, we're given a standard form. And in standard form, we're going to place our terms in descending order from the greatest to the least. And we are already given that. Now it looks pretty good already. But what we are not given, we're not given a factored form, and so we can't see what the zeros are. So we're just going to find a viewing window, and to do that, we'll go to the calculator. And I previously entered in red this function for problem 19. Here I've activated it in graph, and so we can see the nearly vertical portions of the curve that demonstrate that we have a 0 at x equals -5, at x equals 2, and at x equals 7. So let's go ahead and find a window that makes this work, and we can experiment with different things. I'm going to try, and I've done this previously, -150 and positive 150, I'll call it, and I'm going to go by tens. And so we graph, and this is what we see. Here we do see the extrema and the x-intercepts. So we're going to say, for this one here, our window is going to be our x minimum is equal to -10. Our x maximum is equal to +10. Our y minimum is equal to -150, and our y maximum is equal to 150. And we can see everything just fine. And as far as what our end behavior is, our end behavior is going to be the limit as x approaches infinity of f of x is equal to, well, let's look at the nature of this function. We have, our nature is going to be odd. It's going to be odd degreed. And it's going to be negative. Now when you have an odd negative, you're going to start low, or start high and end low. So I think we had -5, 2, and 7 as our zeros. And we're going to start high and go through here, come back up here, see our y-intercept at -70, come up here at 2, go up like this, and down again. And this sketch will help us properly assign our end behavior. As x approaches infinity, the limit as x approaches infinity of fx equals negative infinity, and the limit as x approaches negative infinity of f of x is equal to infinity. Starts high, ends low. Alright, next, another problem. In this set, we have exercise 25 through 28. Describe the end behavior of the polynomial function using the limit as x approaches infinity of fx and limit as x approaches negative infinity of fx. And here we have 3x to the fourth power, and for this one, this 3x to the fourth power, this is what we call our leading term. And our leading term is going to be even natured because the fourth power, so we'll say even degreed, positive. And what we're going to have is this. I'm make my xy coordinate plane. We're going to start high, end high, even positive. So the graph will look something like this. It'll start high, come down sharply, then go up on the other side. Do we know precisely what's going to happen? No, it's going to be sort of like an accentuated parabola, possibly. I don't know what everything else is here, but we know the start high, end high. So for our end behavior, the limit as x approaches infinity of f of x is going to be infinity. And the limit as x approaches negative infinity of f of x also equals infinity. So the limit is the same either as we go toward positive infinity or negative infinity. So that's going to be our answer, problem number 25. If we graph this out, we could possibly see a factored form of this, but it's beyond the scope of what we're concentrating on here. Next other problem we have is 27, and here we have a function that is not written in standard form simply because the terms are out of order. If we put this function in standard form from the greatest power term to the least, we're going to start out with negative x cubed, and we have plus 7x squared plus 3x minus 4. And what we have is we have odd degreed, or odd degree, and we have negative. So we're going to start high and low. So we go like this. So we start high, come down like this. We don't know exactly what it's going to do. Ends low. So we can go ahead and write down our end behavior. So the limit as x approaches infinity of f of x is equal to negative infinity, and the limit as x approaches negative infinity of f of x equals positive infinity. So that's going to be it. This is problem 28. You can see the rewrite here. I'll just briefly do the rewrite. Rewrite's going to be negative x to the fourth power plus x cubed plus 3x squared minus 2x plus 7. So I hope you can see that our leading term is this one, negative x to the fourth power, which controls the end behavior of the function. I hope this has been helpful to you. Good luck, and thanks for viewing.